This is the last lesson on nomenclature, and a lot of it really isn't new. We're just learning about one more special type of ionic compound called a hydrate. So the first part of our lesson, we're going to learn about what a hydrate is and why it's important, and then we'll practice the nomenclature, writing the names and formulas. So first thing you need to know, a hydrate is just an ionic compound itself, but what's different about it is it has water molecules trapped to each formula unit, or trapped inside its crystal structure. So if you remember ionic compounds, they're solids at room temperature, and they form crystals, and sometimes during that process, water molecules get trapped inside. Depending on which compound you have, different numbers of water molecules are attracted. You don't have to remember how many there are for each, but you'll be able to learn how to name and write formulas for them. So how does hydrate actually form? So when you have crystal form, sometimes they start off already dissolved in a solution of water. Over time, if that solution has the water evaporate, the crystal starts to form, and some water molecules are trapped inside that crystal in specific arrangements. Now, why this is important is if you're doing any measurements or experiments with ionic compounds and they happen to be hydrates, is that water is going to be part of your solid. So why does this matter? Water molecules in the compounds usually don't interfere with how it actually reacts, but the biggest thing is it adds some mass to your solid. So later on in the course, we're going to do some work with calculating and hopefully do an experiment to look at hydrates and look at its mass. But the mass will be different from just a regular ionic compound, because you can imagine water adds extra weight to that solid. So if you think you're measuring out 50 grams of your ionic compound, it's not going to be 50 grams of pure ionic compound if it's a hydrate. Some of it's going to be the ionic compound, but some of that mass is going to be attributed to the water that's in there. So right now, all we need to worry about is, well, what are the formulas and what are the names and how to recognize them. But later on, we'll see where that can come into play when we're actually doing calculations. Up to this point, all of the ionic compounds we've seen have been ones that don't have water trapped inside. While we haven't given them this official name yet, a more accurate name for those ones fall into this type of category. We call them an anhydrous compound. The word anhydrous means no water. So all of the ionic compounds that we've seen so far, we didn't see any water molecules in their formula, so they were anhydrous. There's none trapped inside their crystal structures. If you do see water molecules now with formulas, then you'll know you have a hydrate. So let's take a look at the nomenclature for hydrates. Now the nice thing is, the first part of the name follows any of the rules for ionic compounds or polyatomic compounds that you've previously learned. So these can be binary ones or ionic with a polyatomic ion. So you have to remember all of those rules, but hopefully by now you've had lots of practice and are getting a lot more comfortable with that. There is an additional part that you have to add to the name, however. So what you want to do, the rule says add X hydrate to the name, where X is going to indicate the number of water molecules that are present. And you do that by using your prefixes. Same prefixes, mono, di, tri, etc. So now let's try some examples so you can see how it works, and then you can try a couple on your own. So here's the first one. I'll walk through this with you. So first thing that you see over here on the left, just to show you comparison, this would be a formula you've already learned how to name. And we're going to call it the anhydrous name here, but really it's just the regular ionic compound from before. So metal and nonmetal, this is binary. This is barium. I don't need any Roman numerals because barium only has one charge of +2. And my nonmetal is chlorine, so we call it barium chloride. Now, if it's a hydrate, you'll see now how the formula changes. Over here, this part of the formula is going to be new, and that's indicating that you have a hydrate. There's always a dot in between to show that they're attracted to one another. They're not chemically bound, it's just an attraction between forces. And then you'll see how many water molecules are bound for every one barium chloride unit you have. And then there's the formula H2O for water. So the first part of the name, if we go back up here to the rules, we name it the same as the anhydrous name. So this is barium chloride. But now we add on the hydrate part of the name. So prefix we use for 2 is di. And then attached to the prefix, all you have to do is add on hydrate. So the name of this compound here is barium chloride dihydrate. So now what I want you to do is try out a couple of examples to make sure you have the right idea about what's going on. So here's one going from the formulas to the names, and here's one going from names to formulas. So pause the video now, try this out. When you're ready, unpause, and you can continue on checking your answers. All right, let's put this together. So we have copper and sulfate. Copper is a multivalent metal. It has more than one charge. Here, +2 is the charge for copper, because we know sulfate has a charge of -2. So in the name, copper 2, or you could say cupric if you wanted to use the classical system. And then we put the polyatomic ion name, which is sulfate. Now over here as a hydrate, again, the dot means water molecules are attracted. And how many there are 5 waters for every 1 copper-2 sulfate. So the first part of the name, name it just like you've already learned. And then prefix for 5 is pent. And here we're going to put penta because we've got hydrate after, not a double vowel. And when we put it all together, that's called copper-2 sulfate pentahydrate. Last one, barium hydroxide on its own. Straightforward polyatomic compound, BaOH2. Now here we want to name it as a hydrate, so you'll notice the first part of the name is the same over here, but again we have that hydrate in there. Octahydrate, octa is for 8, and when you see hydrate, you think water. So the formula, BaOH2, put that nice dot in there, and add H, 2 O's, and make sure you have the 8 in there for 8 of them. And that's how you name hydrates. So hopefully now you can see how to put everything together for a hydrate, and that there's really not a lot new compared to the previous lessons, except we just need to add on that information about the water molecule.